Previously, we learned that supervised learning uses labels. Let's discuss how we can build a classification model or classifier to predict the labels of unseen data. There are 4 steps. We build a classifier which learns from the labeled data. We pass it to it. When we then pass it unlabeled data as input and have it predict labels for this unseen data. As the classifier learns from the labeled data, we call this as a trained data. Okay. So let's build our first model. We'll use the algorithm called k nearest neighbors, which is the popular for classification problems. The idea of k nearest neighbors or KNN is to build the label of any data point by looking at the k. For example, 3 closest labeled data points and getting them to vote on what label the unlabeled observation should have. KNN uses majority voting, which makes prediction based on what label the majority of nearest neighbors have. Here, using this scatter plot, an example, how do we classify the block observation? If k equals to 3, we would classify it as red. This is because 2 of the 3 closest observations are red. If k is 5, we would instead classifying it as a blue. And to build institution of KNN, let's look at this scatter plot. Display total evening charge against total day charge for customers of a telecom company. The observations are colored in blue for customers who have churn and red for those who have not churned. Here we visualize the results of a KNN algorithm where the number of neighbors is set to 15. KNN creates a decision boundary to predict if customers will churn. Any customer in the area with gray background are predicted churn, and those in the area with a red background are predicted to not churn. This boundary would be used to make predictions on unseen data. And here, to fit a KNN model using Scikit-Learn, we import the k neighbors classifier from Scikit-Learn neighbors. Scikit-Learn.neighbors. We split our data into X, a 2D array of features, and Y, a 1D array of the target values. In this case, churn status. Scikit-Learn requires that the features are in array where each column is a feature and each row a different observation. Similarly, target needs to be a single column with the same number of observations as the featured data. We use the dot values attribute to convert X and Y to NumPy arrays. Printing the shape of X and Y, we use the there are 3,333 observations are there of 2 features. There are 2 features are there. We pass in total day charge and total even charge. These are 2 observation we pass in there. and 3333 observation of a target variables. There is these are the target variables. We then instantiate the our k neighbors classifier, setting setting n underscore neighbors as 15 and assign it to the variable kn. Then we can fit the classifier to our label data by applying the classifier dot fit method and passing two arguments, the feature values x and the target values y, and predict unlabeled data. Here we can set we have to set a of we have to here we have a set of new observations x new, checking the shape of x new. We see it has 3 rows and 2 columns, 3 rows through 2 columns. That is 3 observation here, 3 observation are taking, which is unseen data, and 2 features. We use the classifiers dot predict method and pass classifier dot predict and pass it the unseen data as a 2D numpy array containing features in columns and observation in the rows. X new. Printing the prediction returns a binary value for each observation or row in X new. It indicates n. It predicts 1, which correspond to Chan of the first observation, and 0, which correspond to no Chan for the second and third observations. So we predicted using the this is the unseen data. We applied unfitting data. We predicted these values. 1 is Chan, 0 is unchan data. Let's practice. I'm opening my Jupyter notebook. Here already we see there is Chan data is there, zeros and ones, and also this is the data. So as an example, we seen that we have to fit the sklearn. To fit that, first I need to import the I need to import this state this particular this thing algorithm k neighbors classifier. Then we already seen we pick the 2 values. One is account length, and customer call service. We pick the two what you call x values. This is where we are storing, and target value. Last one is the target value. There, this is the target value. This is the target value, and the target value I'm taking k nearest neighbor as a 6. We already seen what is the n neighbors. We are taking as n as 6. Then we are fitting here. Fit this. Once we fit, this is the fit. Then after fitting, this is the fit model. As we seen, then what we need to do, we are taking the new observations. So I will copy these observations. I will paste it here. I will paste it here. So x new is, this is x new, np. First we need to import the np. import and numpy as np. numpy as np. I will import numpy as np. I will pass this thing. I will create. So we created a new new unseen data. Now we are predicting. How to predict? Y is equal to, already prediction is there. Now I'm passing these new values. So we predicted. Now we are printing the values. Now I want to print the values. So I print these values. So 0, 1, 0. This is the, as you see, 0 is not shown, 1 is shown, 0 is not shown. This is where this is the prediction. And that's it. We'll continue in the next session. Thank you.